So welcome back, and we're continuing with our study of Euclidean geometry. This question, we are to decide whether these two triangles are similar or not. So if we take the corresponding sides, so we're talking about this little yellow triangle, and we're talking about the big triangle, right? So if we take this side in the little yellow triangle, compared with the whole side, we're going to get 6 as to 18. 6 as to 18 is 1 as to 3. If we now take this side as to the whole side, we're going to get 5 as to 15. That is also exactly 1 as to 3. But if we take this as to this, we don't get 1 as to 3. 6, 5 as to 14 is not equal to 1 as to 3. And because of that, the triangles are not similar. They're not similar, and the reason that they're not similar is because the corresponding sides are not in proportion. Okay, right, let's look at this. There's two triangles in this figure. There's this little one on the end here, this red stripy one, and there's the big one. Are they similar? Yeah, they actually are. And the reason they're similar is that we've got a common angle. We also know that this angle over here, which I'm going to call Q1, is equal to angle S. Why is Q1 equal to angle S? Well, Q1 is equal to angle S because it's an exterior angle of a cyclic quad. Right, we can't just write cyclic quad. We can write CQ, cyclic quad. Okay? For exactly the same reason, angle R1 is equal to angle P. And now there's two reasons that we could give here. R1 is equal to P because of third angle of triangle or because of exterior angle of cyclic quad. Third angle of triangle might be quicker to write. Okay, now we've got three angles, so the two triangles are similar. Just remember that when we write them down similar, we must write them down in the correct corresponding order. Let's start with T. Let's go in the big triangle, TPS. TPS. We must start with T in the little triangle. We went to angle P. Now angle P is the one with the two double black arcs on. So we must go to the one with the two double black arcs on in the red stripy triangle. We must go to R and X. And then from P we went to S. So we must go to Q. This business of labeling the triangles in the correct order is really, really important because soon we're going to be taking ratios out of the triangles. In other words, we're going to be taking corresponding lengths, and if they're not in the correct order, it's not going to work. All right, let's have a look at question 4. As always, if you haven't tried this question yourself yet, pause the video and try it. Okay, the first question here says prove the triangle CDE. So we're talking about this little yellow triangle over here. Prove that it's similar to the big triangle. Okay. Now, the first thing that is hopefully obvious is that this angle over here is common. It's in both triangles. We are also told that this angle here is equal to that angle there. So now we've got two angles, and if we've got two angles, the third one must be equal. So in fact, we only need two, but we are always expected to show why the third one is equal and then write down all three. But once we've got two, we know we can do it. Right, so let's write it down. Angle C, common. CED, that's that angle there, CED is equal to CAB. And the reason for that is given. That was given in the question. Okay, Now, because of that, the third angle in each triangle must be equal. And we're talking about this angle here, CDE, and this angle here, CBA. Right, so we can now write down CDE, angle CDE equals angle CBA. And the reason is third angle of triangle. Okay, and therefore the triangles are similar. As always, let's just make sure we list them in the correct order. Let's start with C. Let's go with the little yellow triangle. Suppose we went CDE in alphabetical order. Then we must go C, because we're starting at C, so we started with C with both. Then we went to D, that's the one with the green dot on. So we must go to B, the one with the green dot on. Then we go to E, which is the one with the double arc on. So we go to A, the one with the double arc on. And angle, angle, angle is our reason. Okay. Right. Let's look now at calculating some sides. Okay. So what we know, let's see if we can pull a ratio out of this triangle. For the first time now, we're going to see the importance of having listed these in the correct order. They're asking us to find EC. So in fact, if we took EC out of this little yellow triangle, EC, look at the letters I'm taking. I'm going to overline them with an orange pen. Then I must take AC out of the other triangle. So EC over AC. Do I know AC? Yes, I do know AC. Right? Now we can take another combination out of here and the same corresponding piece out of here. This over this will be the same as, now what we don't want is another one that we don't know. In this yellow triangle we know DC. So if we now take DC from here, right, DC from here, then we must take BC from here. Do we know BC? Yes, we do. Okay. Now the reason for this similarity, so for these ratios being equal, is because we've got similar triangles. Okay, that's why we're allowed to do that. And do you see why it's so important that we've got the order of the triangles correct? Okay, now what's really, really important at this point is to just understand why this works. Okay, and what we've essentially got